In this video, we are going to continue talking about the Laplace transforms of unit step functions. So we derived this result from my previous video. So this one is the unit step function, right? So this is the unit step function, and this one is what we call the Heaviside function. Heaviside function. Right, so we derive the Laplace transform of the unit step function, and the result is this, and that of the Heaviside function is this. So what I have to do is just to have e to the negative sa. You will be given a in the question, and then you have to multiply by the Laplace transform of the unshifted function. And this is the shifted function. So the unshifted function is just going to be f of t. Right, so we are going to apply the results in this table to find the Laplace transforms of three different unit step functions in this tutorial. So let me remind you about the definition of the Laplace transforms of unit step function. So let's go ahead with the definition of the unit step function first. So the unit step function is 0 for t less than a, so that is at a particular time. So when t is less than a, this unit step function is 0. But it switches to 1 if t is greater than or equal to a. You can use any constant here. Some textbooks use c. So this is also the definition of the Heaviside function. This is the unit step function multiplied by a shifted function of time. So if t is less than a, the function is 0. The reason is because if t is less than a, the unit step function is 0. 0 multiplied by this, everything is 0. Right, but if t is greater than or equal to a, what do you have? If t is greater than or equal to a, this unit step function is 1. So we just multiply 1 by this one. That's what we have here. So these are the definitions of the unit step function and that of the Heaviside function. So let's apply this definition and use the results obtained from my previous videos to find the Laplace transform of three different unit step functions. So the first one is what I wrote here. So this one is question 1, right? So how do you take the Laplace transform of this? So we have to compare this one to this. How can we write this one in the step form? This one, we have to write it in the step form to be able to take the Laplace transform of. So comparing this to what we have in our definition for the Heaviside function, f of t can also be written as this. That is going to be u of t minus a. What is a in this case? A in this case is pi. That is our threshold. That is the value of t in which the function will change its behavior. So this is pi. Right, and we have to multiply it by f of t minus a. So here our function here is what? Our function here is just sine of 3t. So we just have to multiply it by sine of 3t. And this is the step form of this function. If we want to take the Laplace transform of this f of t, we have to write it in the step form. So now we have to make it conform to this. We have to make our function to conform to this. This one is just sine of 3t. So this one is 3t. I beg your pardon. So this one is 3t. I'm sorry about that. All right, so this is what we have. So we will have to shift this function by pi, right? So let me go ahead and do that before we can take the Laplace transform. So f of t is equal to, this is u of t minus pi, and then sine of 3t. So t, what I'm going to do, I'm going to subtract pi, which will conform with this. But I can't just subtract pi, I have to add pi. So t minus pi plus pi, like this. So minus pi plus pi is 0, then the function is preserved. So you have f of t to be equal to u of t minus pi, right? And then you have to group this one into 2. So we have sine of 3 into t minus pi, like this, and then plus 3 pi, all this one in sine. So this one is the angle. So we have to use the double angle identity here. You know, from the double angle identity, we know that sine of a plus b, right? We know this. Sine of a plus b is sine of a. Cosine of b plus cosine of a times sine of b. All right, so now we can use this to expand our function. So this is u of t minus pi. right? Call this one A and this one B. So now let's expand. So using the double angle identity, this one is sine of what? So this one is sine of 3 times t minus pi, like this, and then cosine of 3 pi, right? And our next one is going to be plus cosine of 3 into t minus pi, like this, and then we have sine of 3 pi. Cool. So what is sine of 3 pi and what is cosine of 3 pi? Right, so let me write that. So sine of 3 pi here is equal to 0, right? And then cosine of 3 pi, what is cosine of 3 pi? Cosine of 3 pi is going to be -1. So let's plug them into our function. So our function f of t here is going to be u of t minus pi. This is multiplied by sine of 3 into t minus pi, like this. But cosine of 3 pi is -1. So that is going to be multiplied by -1. So multiplied by -1. But sine of 3 pi is 0. And 0 multiplied by this, everything is 0. So I'm not going to write that. So we have f of t. This is equal to -1 all the way in front. You have negative. Then u t minus pi, this is multiplied by sine of 3 into t minus pi, like this. Cool. So now we can take the Laplace transform of this, right? So now we are ready to take the Laplace transform. Now the Laplace transform of the function f of t, this one is equal to negative out the Laplace transform of the Heaviside function multiplied by sine of 3 times t minus pi, like this. So just to refresh your memory, so if you have the Laplace transform of the Heaviside function u of t minus a multiplied by f of t minus a, this one is equal to e to the negative sa multiplied by the Laplace transform of the unshifted function. So let's solve this now. So the Laplace transform of this function f of t, this is equal to negative into, so e to the negative sa, a in this case is pi, right? So that is going to be s pi or pi s. So let me call it pi s, like this. And then we have to multiply by the Laplace transform of the unshifted function. So the unshifted function in this case is what? So the shifted function is a sine of 3 t minus pi. This is the shifted function. The unshifted function is going to be sine of 3 t. So how do you take the Laplace transform of sine of 3 t? And that is going to be 3 divided by s squared plus 3 squared, like this. So this one is going to be negative e to the negative pi s multiplied by 3 all over s squared plus 3 squared is 9. So finally, the Laplace transform of the function f of t, the very first example, is -3 e to the negative pi s divided by s squared plus 9. And this one is the answer to our beautiful unit step function or Heaviside function. All right, cool. So let's go to the second one, right? So this is the second one. So the second one is this. We are going to find the Laplace transform of this function. This one is equal to this. So it's the same thing. So you have 0 if t is less than 1. And then you will have sine of 2t. Sine of 2t if t is greater than or equal to 1. Cool. So we have to write this one in the step form. So let's write this one in the step form. So the step form f of t is going to be equal to, it is 0 for t less than 1, so it doesn't matter, but this, so the function is going to be, so the unit step function here is going to be ut minus 1. So a in this case is 1, that is the value of t in which the function will change your behavior. And then we multiply by the function. So after 1, it is behaving like this. So that is going to be sine of 2t. But this is not conforming with what we have. We have this. We have the Laplace transform of the unit step function multiplied by the function shifted by a, the Heaviside function. This one is equal to e to the negative sa times the Laplace transform of the unshifted function. So but you have to shift this t by 1. So let's do that before we can take the Laplace transform. So f of t is equal to u t minus 1. Here I'm not going to shift it by pi, I'm going to shift it by 1 because we want it to conform with this. So that is going to be sine of 2 into t, right? So I'm going to shift it by 1, but I can't just subtract 1. I have to nullify the effect by adding 1 like this. Alright, so f of t is equal to u t minus 1, and then I'm going to have sine. Let's group this one into 2 now. So this one is going to be 2 into t minus 1 plus 2 like this. So now using the double angle identity again, so I'm going to write it here again. Sine of a plus b, this is equal to sine of a cosine of b plus cosine of a and then sine of b, correct? Now let's apply that here. This f of t is equal to u t minus 1. This one is a and this one is b. So let's do that. So this one is multiplied by sine of a. A is 2 into t minus 1. And then cosine of b. B in this case is 2. Plus cosine of a. That is cosine of 2 into t minus 1 like this. And then sine of b. That is sine of 2 like this. So let's distribute with f of u of t minus 1. So this one is going to be, this cosine of 2 is a constant, so I'm going to bring it out here as cosine of 2. Then I'm going to have u t minus 1 multiplied by sine of 2 times t minus 1. So we see that we now have the sine function which is shifted by 1 conforming with this. Cool. Now this sine of 2 is also a constant. I'm going to bring it in front here, and then I'm going to have u t minus 1 multiplied by cosine of 2 multiplied by t minus 1 like this. I think we are safe now. We can take the Laplace transform of this. So Laplace transform of the left hand side is this, and now let me apply the linearity property of the Laplace transform straight away. So this cosine of 2 is a constant, has nothing to do with t, so this one is going to be in front here. Then I'm going to take the Laplace transform of u t minus 1 multiplied by sine of 2 times t minus 1. I'm done with this. Next, sine of 2 is a constant, so I'm going to bring it in front here. Then I have the Laplace transform of u t minus 1 multiplied by cosine of 2 times t minus 1 like this. So now let's apply our formula. So the Laplace transform of u of t minus a multiplied by f of t minus a is e to the negative sa multiplied by the Laplace transform of the unshifted function. So the Laplace transform of this function, the second one, is going to be cosine of 2, which is a constant. Now let's apply that here. This is going to be e to the negative sa. So s times a in this case is 1, right? So a in this case is 1, so s times 1 is s on top here. This is multiplied by the Laplace transform of the unshifted function. The shifted function is sine of 2 times t minus 1. The unshifted function is going to be sine of 2t. So just pretend as if the shift does not exist. So we find a Laplace transform of sine of 2t. And sine of 2t, the Laplace transform is going to be 2 divided by s squared plus 2 squared. Cool. Now plus the next one, which is this one, that is going to be sine of 2. Now the Laplace transform of this, that is e to the negative sa. E to the negative sa. S times a in this case is 1, right? So s times 1 is s on top here, multiplied by the Laplace transform of the unshifted function. The shifted function is cosine of 2 into t minus 1. The shifted function, the unshifted function is going to be cosine of 2t, and the Laplace transform of the cosine of 2t is going to be s divided by s squared plus 2 squared. So this is what we have. So the Laplace transform of f of t, this is equal to what? So now we will have this. So we are going to have e to the negative s out because that is common, and now you are left with this. So now you are left with 2 times cosine of 2, right, divided by s squared plus 2 squared is 4. Now plus what is left on top here is sine of 2, and this is multiplied by s divided by s squared plus 2 squared is 4, like this. So we can further factorize this one out. Why not make it simpler? So finally, the Laplace transform of our second function, this is equal to e to the negative s divided by s squared plus 4. And now what do you have inside? This one is 2 times the cosine of 2 plus s times the sine of 2, like this. And this one is the Laplace transform of a second function. Now let's go to the last one. So the last one permits me to do it in white pen. So the third one, that's quite easy. So we are going to have f of t to be equal to something like this. So that is 0 if t is less than 2. But then we will have this, that is e to the 3 multiplied by t minus 2, and this is multiplied by sine of 4 into t minus 2, like this. That is if t is greater than or equal to 2. This one is surprisingly easy. So now let me recall the formula. So the Laplace transform of the Heaviside function u of t minus a, right, multiplied by f of t minus a. This one is equal to e to the negative sa multiplied by f of s. The Laplace transform of the unshifted function. So let's use this one to solve it. So now let's write this one in the step form. Why not? So in the step form, it is going to be equal to what? So it is 0 for t less than 2. So we are going to have u of t minus what value exactly? So the threshold is 2. So that is the value of t upon which the function will change the behavior. Then you are going to multiply by the function f of t minus a. But in this case, it's f of t. That is this guy. So we are going to have e to the 3 multiplied by t minus 2, and then sine of 4 into t minus 2, like this. So surprisingly, this one is already shifted for us. You don't need to do a shift because this is u of t minus 2, but the function here is already shifted. So we just have to apply the formula straight away. So this is the shifted function. Let me write it for you. So the shifted function is what? The shifted function is e to the 3 t minus 2, and then sine of 4 t minus 2. This is the shifted function. Let me write the unshifted function for you. The unshifted function here is e. So just pretend the 2 is not there. So that is going to be 3t, and then multiplied by sine of 4t. This is the unshifted function. So this one means that we have to take the Laplace transform of the unshifted function. So, and just multiply by e to the negative sa, and a in this case is equal to 2. That is 2, the value of t upon which the function will change a behavior. Alright, so now we know that a to be 2. We just have to find the Laplace transform of the unshifted function, which is this. So how do we take the Laplace transform of this one? So now let me do that. So let's say the Laplace transform of this guy, e to the 3t, this is multiplied by sine of 4t, like this. So this one is the Laplace transform of sine of 4t, but the s variable is going to be shifted by 3. That is the constant in the exponential function. So the Laplace transform of the sine of 4t is going to be 4 divided by s squared plus 4 squared. Right, but we are going to replace s to be equal to s minus 3. That is the constant in the exponential function. So we are going to shift the s variable. So this is going to be 4 divided by, replace s with s minus 3. That's going to be s minus 3 all squared plus 4 squared is 16. And this one is the Laplace transform of e to the 3t multiplied by sine of 4t. And this is the Laplace transform of the unshifted function. So now that we have this, why not? We can go ahead and take the Laplace transform of what we have. So the Laplace transform of the function f of t, this is equal to the Laplace transform of what we have, that is u of t minus 2 e to the positive 3 into 3 minus 2 into t minus 2, and then sine of 4 into t minus 2, like this. Okay, so now this one is equal to what? We can finish it here. So this is going to be e to the negative sa. A in this case is 2, right? So that's going to be 2s multiplied by the Laplace transform of the unshifted function. So the Laplace transform of the unshifted function is what we have here, right? So I'm just going to multiply this one by 4 divided by s minus 3 all squared plus 16. All right, so let's wrap it up here. So the Laplace transform of f of t, this is equal to 4e to the negative 2s divided by s minus 3 all squared plus 16. And this one is the answer to our third and final function. And that concludes this video. So this is the Laplace transform of Heaviside functions or unit step function multiplied by shifted trig functions. And this one concludes part 3 of the Laplace transform of unit step functions. In my next video, I will solve the Laplace transform of a unit step function, a Heaviside function with more layers or more complicated signal. So if you enjoy this video, please give me a thumbs up and subscribe to Calculus Diaries, and join me in my next video as we continue solving the Laplace transforms of more advanced unit step functions or Heaviside functions with more layers. I thank you so much for watching, and then I will see you in my next one. Bye bye.